Well, welcome to section 3.5. It's our last section on arithmetic, and we're going to be working with decimals and the decimal representation of numbers. Most people want to avoid fractions anyhow, so maybe you go with decimals is a good thing here. So here is our place value system, just as a refresher, right? Everything are powers of 10. Every place value is a power of 10. When you get to the decimals, we have this here to denote the decimal point. So here is 10 to the negative 1. These are tenths, then hundredths, then thousands, etc. 10,000s. And it's just sort of the inverse of up here. So we had a number like 2374. We could use money to denote that. We would have two tens, so two $10 bills, three $1 bills, 7 tenths. A tenth is a dime, tenth of a dollar, 7 of those, and 4 pennies, which are hundredths of a dollar. So there's the representation of a basic number, $23.74. It should be clear that when adding or subtracting decimals, you would line up the decimal places, right? You don't add dimes and pennies, just as you don't add cats and dogs. So there is a representation of doing addition. 2374 plus 819. I'd add 9 and 4 and get 13. 13 pennies, however, is 1 dime and 3 pennies. So you would move the dime over here. This is nothing that you haven't seen before. So this one we're going to do on its own separate video. So in our first example here, we're going to subtract 8.25 from 11.04. So I go to the hundredths place, which is the pennies, 10 to the second, and I have 4 minus 5. Well, I can't subtract 5 from 4, so I am going to borrow or regroup, and I can't regroup until I get to the $1. So I'm going to take the $1 and move it over to the dimes, and that gives me 10 dimes. And then I'm going to take 1 dime, subtract it, and move it over to the pennies, and that's going to give me 14 pennies, right? So 14 minus 5 is 9. Put the 9 here. 9 dimes minus 2 dimes, or 9 tenths. This is really just 9 tenths minus 2 tenths will give me 7 in the tenths place, or 7 tenths. Here I have no dollars, I'm subtracting 8. I can't do that, so I'm going to take my one $10 bill and move it over here, and that would give me 10 $1 bills, and add that to what I have, and I get 10 $1 bills, subtract 8, and I have 2. So there's the decimal. $11.04 minus $8.23 will give me $2.79. So in this example, I'm going to convert 0.4305 to a fraction. Now there's a trick to this. The answer is going to be 4305 over 1 followed by 4 zeros. So it's 4,305 over 10,000. And the trick is there's always as many zeros as there are numbers to the right of the decimal. But let's show why that why that trick works. So I have 4/10 plus 3/100 plus 5/10,000. So I want to add these. And how am I going to add them? I'm going to find an LCM, right? Which is going to be 10,000. So I'm going to convert 4/10 into a new fraction that has a denominator of 10,000. And I'm going to convert 3/100 into a new equivalent fraction that has 10,000 as a denominator. So to do this, I would multiply by 1,000, right? 10 times 1,000 is 10,000. And multiply the numerator by 1,000. 4 times 1,000 is 4,000. Here I'm going to multiply by 100. 100 times 100 is 1, followed by 4 zeros, which would be 10,000, and the numerator by the same number, because I'm multiplying by 1, right? So that's 300. So I have 4,000 over 10,000 plus 300 over 10,000 plus my original 5 over 10,000. So that's 4,305 over 10,000. So that's the long way of doing it. The short way of doing it would just be to recognize that the pattern is always going to develop. So another example would be 0.235 or 251. Convert that, it's going to be 251 over 1,000. See that? So I'm going to order these from least to greatest. Well, they're all equal. Now, why are they equal? Well, 0.9 is just 9/10. 0.900 is 9/10 plus 0/100 plus 0/1000. And any number, add 0 to any number, you're not going to change the number. And you can follow the logic on that one too. So now we're going to go the other way. We're going to change fractions into decimals, these two fractions. Sometimes it can be really easy because all decimals, right, every decimal has a denominator of either 10, 100, 1,000, etc., right? So 7/20ths, if you can recognize that 20 multiplies easily to 100 by multiplying by 5, I can multiply the numerator and denominator by 5, which is basically another form of 1, and I'm going to get 35 over 100. And that is now a decimal denominator. So it's going to be 0.35 as a decimal. This one, 3 over 11, it's hard to find, hard to make it 100, can't make it 10. It's just, maybe I can make it 1,000, but I don't know. So the other way of doing it is simply dividing. 3 divided by 11. Now some students make the mistake of doing this. So 11, 3 goes into 11 3 times, and you should recognize right now you've made a mistake. Because you're not going to get a number 3 something when you divide for this number here. This number is clearly less than 1. That's 1. So this number is clearly less than 1, so this would be wrong. So here I'm going to get no 1s, which I kind of know that. And then I'm going to put the decimal place. And really what I'm going to do is take the 3, and I'm trying to find out how many tenths go into this number. So I'm going to take 3, which is 3 over 1, multiply it by 10 over 10, and I'm going to get 30 tenths. And I'm just going to put that here, a 0. That's no longer 3, it's 30 tenths, which is 3, but I changed it into tenths. I'm going to find out how many tenths I can get into this, and the answer is 2. I get 2 tenths. And 2 tenths times 11 is 22 tenths. I subtract it, and I got 8 left over, but 8 what? And the answer is 8 tenths. So then I'm going to take the 8 tenths and turn them into hundredths by multiplying by 10 over 10. And I get 80 hundredths. So you may have recalled that you just keep adding a 0, but what you're doing is changing it to the next place value to the right. So now I have 80 hundredths. How many 11s go into 80 hundredths? The answer is 7. 7 times 11, actually it's 7 hundredths times 11 is 77 hundredths, with 3 hundredths left over. Add a 0, I'm changing 3 hundredths now to thousands, and I can get 2 in there, so that's 22 with 8 left over. Now I'm going to change thousands into 10,000s, and I get a 7, and now you can see this is just going to continue to repeat. So the answer would be 0.27 repeating, and that's how the repeating sign is. So that's really 27, 27, 27, 27 forever. So multiplying a decimal by a power of 10 is very simple. It's easier to do in your head than it is on a calculator. So here is our decimal point here. And I'm going to put this number in. It's 12.67. And I'm multiplying it by 1,000. 1,000 is 10 to the third, which means 10 times 10 times 10. So there's 1,000. There's also 3 zeros. So multiplying it by 10 is going to shift it 1 decimal place. Multiplying it by 100, it's going to shift it 1 more decimal place. And multiplying it by 1,000 is going to shift it 1 more decimal place. So there is our answer. 12.67 times 1,000 is 12,670. And you don't have to go through this whole process. You could have just done 12.67, move the decimal 3 places, 1, 2, 3, put a 0 in for a placeholder, and you got the number. So in this example, 3.32a, we're going to divide by 1,000. That's the same as this here. And let me just explain this. 10 to the negative 3 is 1 over 1,000. Taking 6.23 and multiplying it by 1,000 is the same as taking 6.23 and dividing it by 1,000. So multiplying by 1 over 1,000 is the same as dividing by 1,000, which we've gone over several times now, right? That idea. Sometimes it's displayed this way on your calculator. And e to the negative 3 means 10 to the negative 3 power, which is the same as 1 over 1,000. So these are different ways of, you'll see this more when you type into Excel, and you'll see this more in this form on your calculator. It's just conserving space. E means raised to the 10 to the whatever power. And the whatever power is that negative 3. So we're going to ship this one 3 place values to the right. So multiplying by 10, I'd move this way. Dividing by 10, I would move this way. I got to divide by 3 tens. So there's 1, 2, 3. And I use my zeros for placeholders. And the answer is 0.00623. So in this example, 3.32a, we're going to divide by 1,000. That's the same as this here. And let me just explain this. 10 to the negative 3 is 1 over 1,000. Taking 6.23 and multiplying it by 1,000 is the same as taking 6.23 and dividing it by 1,000. So multiplying by 1 over 1,000 is the same as dividing by 1,000, which we've gone over several times now, right? That idea. Sometimes it's displayed this way on your calculator. And e to the negative 3 means 10 to the negative 3 power, which is the same as 1 over 1,000. So these are different ways of, you'll see this more when you type into Excel, and you'll see this more in this form on your calculator. It's just conserving space. E means raised to the 10 to the whatever power. And the whatever power is that negative 3. So we're going to ship this one 3 place values to the right. So multiplying by 10, I'd move this way. Dividing by 10, I would move this way. I got to divide by 3 tens. So there's 1, 2, 3. And I use my zeros for placeholders. And the answer is 0.00623. So in this one, we're going to divide. We're going to take 12.6 and divide it by 0.63. Now, I don't have any convoluted way, like in the last one, of doing this, but this is what I'm going to do. I'm not going to divide with decimals. It is just too hard. So what I'm going to do is take this basic, this is, you know, it's like a fraction, and I'm going to alter it. I want whole numbers. So to get whole numbers here, I have to multiply by 10, right? But to get a whole number on the denominator, I have to multiply by 100. So I want all the decimals gone. So I'm going to multiply the bottom by 100, and I'm going to multiply the top by 100. And if I do that, I move the decimal 2 places here, and I move the decimal 2 places here. Right? Now I also can see that this is just going to be 126 times 10. I mean, importantly, that number there and that number there are the same number. right? I just multiplied it by 1. So I just changed the form of it, but I did not change the actual value of it. They're equivalent. They're equal. That and that are equal. So I'm going to split this. I see I have a 0 here, so that's a 10. So 1260 is the same as 126 times 10, and 63 is just 63. 126 divided by 63 is just 2, right? And 2 times 10 would be 20. This is just a brief example of how to estimate, right? It's not a science. It's sort of like, okay, well, I'm going to use whole numbers. I'm going to change all these into whole numbers. The closest whole number to this is 1. So I'm going to say that's 1 times, this is closer to 2 than it is to 1. So 1 times 2 times, and this is closer to 5 than it is to 4. So I'm going to estimate that to be 10. That is the estimate. So I picked a couple homework problems. Number 2, and students often have trouble looking at this, so let me break it down. So I have 5, and that's a raised to the negative 1, plus, and hopefully you can see this, 10, 7 of these 10s raised to the negative 1. So 5 raised to the negative 1 is 1/5. Plus 7 raised to the negative 1 is 7/10. This is 2/10, right? Multiply the top by 2 and the bottom by 2, so that's the same as this. So I'm going to get 9/10. And I can write that as a decimal as 0.9. This one here, I have 6 times 1/10 plus 5 times 1/10, right? So I have 11/10. You follow that? 6 times 1/10 is 6/10. And that's plus, it's a plus sign. 5 times 1/10 is 5/10. So 11/10 is 1 and 1/10. So I'm just going to do a couple of these. I'm going to do like this one here. I'm going to put it up here. Here's the decimal point here, right? So this is 1/10, 2 1s, and 3 10s. And I'm going to multiply it by 10. That means I'm going to shift it to make it 10 times bigger. So I shift, and shift. So 12.3 times 10 is 123. And the other one I want to look at is this one here. So I have 3450 times 10 to the negative 2, which is right here, 1/100. So you need to recognize that that is the same as 3450 divided by 100. And so if I take 3450 and divide it by 100, I'm going to shift it 2 decimal places to the right. There's 1, there's 2, so there's 3450. The decimal's right here, so the answer here is 34.50. So hopefully you know that that is multiplying by 10 to the negative 3 is the same thing as multiplying by 1/1000, which is the same as dividing by 1000. So this is what that is. So 0.5, I'm going to do a couple of these. 0.58, you're going to write, give it a decimal, write it as a fraction, give it a fraction, write it as a decimal. This is problem 3. So the long way, of course, is say this is 5/10 plus 8/100. So I'm going to change tenths into hundreds. Which is 50 over 100. Which is 58/100. But if you have, you can almost, it's really easy to just see that that's 58. And you have 2 place values. So that's the hundredths place. So, I don't know, it should be pretty easy to do that one. 4/5, I recognize that I can easily get to one of my decimal denominators, which is a 10. So that's just 8/10, so I can write that as 0.8. This one you should be able to do in this manner, and this one you're just going to have to divide it. Right? This one, hopefully you can get these. So I'm going to do one of each of these, a multiply and divide, because the technique's a little bit different, right? So I'll do this one. I'm not going to multiply with decimals. So in order to make this 0.07 into a whole number, I'd have to multiply it by 100, which shifts the decimal 2 places. So I'm just going to multiply this whole thing by 100. And so after I multiply it by 100, the order which I multiply doesn't matter, so that's going to be 7 times 11. And 7 times 11 is 77. But I'm not done, because I can't just multiply this by 100 and say now I have 77. No, now I'm going to have to divide this by 100. Dividing by 100 will move the decimal 2 places to the left. So the answer is 0.77. So this one you would multiply by 102, and you'd wind up with 12 times 21. Multiply that, and then divide it by 100. With division, you don't have to do that, right? What you're doing with division is just making another equivalency. So I have this. I need to multiply the bottom by 100. So I'm going to multiply by 100. That'll get rid of all the decimals. But I'm multiplying by 100 over 100, which is 1. So this shifts the decimal 2 places. So I get 340. Divided by, this shifts the decimal 2 places. I get 17. So 34 divided by 17 is 2 with an extra 0, right? So it's 20. Now, do I have to do anything to this? No, because this number here and this number here are the same number. They're just different representations of the same number. In the same way that 1/2 of an inch is the same as 4/8 of an inch, right?